Welcome to Maths with EJD. We're talking about coordinate geometry, and the next three videos we'll be talking about circles. In the last three videos, we talked about lines and things like parallelism and perpendicularism, intersection of lines, and how to represent lines generally. So in this next set of videos, I'll be focusing on circles and different aspects of circles like that. Okay, so for starters, let's understand what a circle is. A circle is the set of all points in a plane that are fixed, that are at a fixed distance called the radius from a fixed point called the center. Well, that's ambiguous somehow. Maybe that's not quite clear, but one definition of a circle that I like a lot is this idea that a circle, a circle is the locus, is the locus of points. Change the locus. So take note of locus. Locus of points equidistant. Locus of points equidistant rather from a fixed point. Equidistant from a fixed point. Okay. So that means that if you have, imagine that you have a fixed point this way. Okay. So, and you have this is a fixed point, right? So, and you have the locus of all points equidistant that have equal distance from that fixed point. So imagine that we have, okay, let me use this. You have, maybe this is, let's say this is 3 centimeters or something. Just assuming. So, you have the circle coming from here, then you have another 3 centimeters. It goes locus of all points always equidistant from that fixed point. You have another 3 centimeter. You have another 3 centimeter. I mean, I'm not drawing to scale, so don't mind me. Then you have another, maybe I should have drawn to scale actually. So you have another 3 centimeters like this, another 3 centimeters, 3 centimeters, 3 centimeters. So by the time you join it all up, then that is a circle. So that is what it means to say that a circle is the locus of points equidistant from a fixed point. So that's what a circle is in another way. But what we have here says a circle is the set of all points in a plane that has a fixed distance, which is called the radius, from a fixed point called the center. So the standard equation of a circle is what we see here. So given a center h comma k and radius r, the general equation of a circle can be expressed as x minus h squared plus y minus k squared equals r squared. Okay, so it's more like when we come back here, and then we have this, and let's say this is the center of a circle. Okay, let me try to do some scaling 2, 4, 6, and say 2, 2, 4, like that. And we have a circle centered at 3, comma 2. Okay? So the center of the circle is at 3, comma 2. So we have this. So the center now, h, comma k, is what we have as 3, comma 2. And now the deal is, so the equation of this circle can be represented as what we saw there. That's um, x minus x minus h, that's x minus 3 squared, plus y minus k, that's 1 minus 2 squared, equals the radius. I need to know what the radius is here. So, okay, let's assume the radius is, say, let's say the radius is 4. So that will equal to 4 squared. So that means the distance from the center to all these other places is 4, like that. So that is how you write the equation of that circle. That's x minus 3 squared plus y minus 2 squared equals 4 squared. So that is how to write the equation of a circle if you know the center to be hk. X minus h squared plus y minus k squared equals r squared. So that's the standard. So an example is this. Find the equation of a circle with center 2, comma minus 3 and radius 4. Okay, so that will simply be x minus 2 all squared plus y minus 3 all squared equals 4 squared. That's x minus 2 squared plus y plus 3 squared equals 16. By the way, you can represent that using decimals, right? Um, so x minus 2 squared y plus 3 squared equals 16. So you just do this x minus 2, okay, uh, raised to power 2 plus y plus 3 raised to power 2, and all of that is equal to 16 because the radius is 4. So you can see that circle now. So if you look at the center, okay, we know the center is 2 comma minus 3, right? Let me try to locate that center. We have 2 comma minus 3. Okay, so that's the center. Oh, okay, 2 comma minus 3. Yeah, so you see that's the center of that circle like that. Okay, so that's the center, 2 comma minus 3. We can always have that. So with that in place now, so once you know the center, you can write the equation of a circle. Now, it is also possible that you have a circle with center at the origin. So in that case now, so for circle at center, with center at the origin, right? Okay, let me do this better. Example 2. Okay, circle with center at the origin. If the if the center is at 0, 0, that means HK now is 0, 0, 0. The equation reduces to x squared plus y squared equals r squared. In simple terms, this is what we mean by that. You come here now and you have your you have this, and this is the origin. So the center of the circle is at the origin. So if you just follow the same thing we did the other time, so that means that the equation of the circle, the origin is 0, comma 0. So that means that the equation of the circle will be x minus 0 squared plus y minus 0 squared equals the radius, whatever. Okay, this is radius now. This is radius, this is radius, this is radius, or any other line like this is radius. Okay, so x minus 0 squared, because the circle has center at the origin, x minus 0 squared plus y minus 0 squared equals r squared. That means you have x squared plus y squared equals r squared. So that is what that reduces to if the center of the circle is at the origin. Okay, so now we have a question. Example 2 now. Circle with center at the origin. Find the equation of a circle with center at the origin and radius 5. Of course, that will be x squared plus y squared equals 5 squared, which is simply x squared plus 5 squared, plus y squared equals 25. Okay, maybe I should just do this. X squared, x raised to power 2, okay, plus y raised to power 2 equals 25. So that's the circle right there. Maybe this can go now. Okay, so the center is at the origin, of course. So and the radius is 5. So that's that. Now, how do you know? If the radius is 1, this is what you get. So when the radius is 2, you know it expands. Okay, let me even do it step by step. So I have this x squared plus y squared equals 1. Okay, x squared plus y squared equals 4. In that case, the radius is 2. X squared plus y squared equals 9 with radius 3. Of course, you can have other numbers. It doesn't have to be a perfect square. Because if I do radius 6 now, we also have that. But I'm just doing the perfect squares. Then x squared plus y squared equals 16, the one we just did. Then x squared plus y squared equals, say, 25. That with 5 as radius, right? So x squared plus y squared equals 36. X squared plus y squared equals 49. So you can see that so as the radius increases, the circle keeps expanding like that as expected. Okay, so here now, so we have another question which says, check if a point lies on the circle. How do you check if a point lies on the circle? Well, the easy thing to do is, you check. So if you to check if 3 and 4 lie on a circle, just do 3 squared plus 4 squared. And once you do that, if the answer you get is equal to the square of the radius, then it means that the equation, the point lies on the circle. So a mathematical way to do that is this. So I can say that I can simply say that if A comma B lies on a circle, okay, then A squared plus B squared will be equal to the square of the radius of the circle. Simply. So that's what that is about. So if you want to check if a point lies on the circle, just square each of the ordinate and abscissa, square them and add together. If it is equal to the square of the radius, then the point actually lies on the circle. Then of course you can also do it graphically, right? You want to find out if 3, comma 4 lies on x squared plus 5, y squared plus 5. So you just come here. Okay, so x squared plus y squared equals 25, right? Okay, control Z, yeah. So let's leave the 5 alone. Then we now see 3, comma 5. So you can also do it graphically. So you can plot the circle and then then locate the point. So you see 3, comma 4 lies on the circle. So this is the graphical way to represent that. Isn't that interesting? Okay. So another thing is you want to determine the center and radius of a circle. So the question here says find the center and radius of the circle, right? So we already know, so the circle is x minus 5 squared plus y plus 2 squared equals 36. Of course, we can already see the radius here is square root of 36, which is 6. And then the center is 5, comma minus 2, because this is 5, 2. Well, let me just show the standard way to get that. Okay, we want to find the determine the center and the radius of a particular circle. So here, the circle is x minus 5 squared plus y plus 2 squared equals 36. So, okay, find to find the center, and radius, okay, of this now. Okay, what do? You compare with the standard equation. You compare with the standard equation. Okay. So if you compare that with the standard equation is x, standard equation, okay, with center h comma k. That's be x minus h squared plus y minus k squared equals r squared. So if you compare, so you see that here, um, x, so you can just compare x minus 5 is similar to x minus h. So that simply means that if you cancel x, minus 5 is equal to minus h. So h is equal to 5. We have that. The next one, then you have y minus k, is equal to y plus 2. So y minus k is equal to y plus 2. Y again cancels out. So you have minus k equals 2. That means that k is equal to minus 2. Okay. So with this now, we have center is equal to h comma k, which is simply the same thing as 5 comma minus 2. And then for the radius, we already know the radius is r squared. I mean, the radius is r, and we know r squared is 36 here. So r squared is 36. That means that r is square root of 36. And then the radius is 36. So center is 5 comma minus 2, radius is 36. So that's the standard way to answer that question. Okay. Of course, if it is multi-choice, if it is objective and not theory, you can just read it off from here. So, you already know this is, uh, once you have minus here, it means that you just pick this 5. If it is plus, you pick minus of whatever you have. That's why you have 5 minus 2, and the radius is square root of 36. Then the question, we have another interesting question, which says to convert expanded form to standard form. So you have an expanded form, you want to convert it to the standard form of the equation. We know the standard form is x minus h all squared plus y minus k all squared, all right, equals r squared. So you want to do that, right? So you want to convert expanded form to standard form for this. Of course, if you go through all that, we can then read off the center and the radius from that. But this is what we have: x squared plus y squared minus 6x plus 8y plus 9 equals 0. So we want to write this in standard form. So we need to show that. Let's show that the way it is. Um, so we can say that to convert x squared plus y squared minus 6x plus 8y plus 9 equals 0 to standard form. Okay, I want to make it standard. To convert that to standard form. All right, what do we do? So the first thing we want to do, we uh use use the completing the square method. Use the completing the square method. I mean, this is very useful. Completing the square method. This is useful for quadratic equations. Okay. So now you have x squared plus y squared minus 6x plus 8y. Okay. Plus 9. Is that what I did? Yeah, plus 9 equals 0. So what do? We put all the x's together and put all the y's together. Okay, and then the constants will be on its own. So we have now x squared minus 6x, okay, plus y squared minus 8y, okay, plus 9 equals 0. Just rearrangement. So the next thing we do is to complete the square. Now, how do we complete this square? What we simply do is we have x squared, okay, minus 6x plus. So to complete the square, now we take this minus 6 now. We say minus 6, all right, divided by 2 and square it. That's how to complete that square. But by the way, whatever this is, we have to have it outside. Okay, so to balance this up, we know we need to uh as you add this, you subtract it. You subtract minus 6 over 2, okay, completing the square now, minus 6 over 2 all squared. So plus and minus, so it's more like these two don't exist, but we need them to move on. And then for the y part now, you have y squared minus 8y. Is it minus 8y? I think it's plus 8y. Yeah, I think it's plus 8y. So y squared plus 8y, and then we have 8 over 4 plus 8 over 4 squared minus 8 over 4 squared, so that we can easily cancel that. So it's as good as we have not done anything. Okay, and we add this, then plus 9, okay, plus 9 equals 0. So now we can tidy things up. So we have here now, we have x squared minus 6x, then minus 6 over 3 is minus 3. Minus 3 raised to power 2 is 9. So we have plus 9, then minus 9. Then we come here also, we have plus y squared plus 8y. Then 8 over 4 is 2. Okay. 8 over 4 is 2. No, okay, that's my fault. It should be 8 over 2. I was wondering. It should be 8 over 2, not 8 over 4. 8 over 2. Okay, so we now have 8 over 2 is 4. 4 squared, that's plus 16, then minus 16. So it's as good as this and this cancel out. So, but we need to put them there. Then plus 9 now equals 0. So what do we have? We see x squared minus 6x plus 9 is now a perfect square. All right. Then plus y squared plus 8y plus 16, another perfect square. But then we have minus 9 minus 16 plus 9. So 9 and minus 9 cancel out. And we just have minus 16 equals 0. Okay. So because these ones are perfect squares now, how do we really express them? Of course, you know that um just like what we did before. So another way to write this is in perfect squares to say x minus that's 6. That's minus 6 over 2 all squared. That's exactly what it would be as perfect square. So this 9 you have here now. Now you got this 9. Then plus y squared. Then in perfect square, that will simply be plus this 8 now. This 8 over 2, all squared. And that's then this minus 16 can become plus 16. So that means you have x minus 6 over 2 is minus 3. So that's x minus 3 all squared plus y plus 4 all squared equals 16. Yeah. So we have x. Oh, what am I doing here? Minus 6 over 2. Um, Minus 6 over 2. So that should actually be negative. Okay. So okay, I think we just need to take the 6 over 2 alone. So we need the 6 over 2 alone. So in this case, now once the minus is already taken outside, so we can just have this is 6 over 2. We don't worry about the sign because of course it will be gone, right? So we have x minus 3 squared plus y plus 4 squared equals 16. So if you compare this, so this is now in standard form. So if you compare this with the standard form now, like this, you have x minus h all squared plus y minus k, y minus k all squared equals r squared. So the center, of course, the center, which is h comma k, will simply be, so minus 3 minus h. Once they have the same sign, just pick positive. They have different signs, pick negative. All right, they have different signs. Then the radius, which is r, is simply square root of 16. Square root of 16, and that is equal to 4. So that's how to write that in standard form, basically. So if you need to write in standard form, you need to complete the square like that. So don't forget, if you are not under any pressure to do it, to find the radius, that analytically like I did, you can just plot it if you can plot. So just plot, so x squared, okay, plus y squared, all right, minus 6x plus 8 plus 8y, okay, plus 9 equals 0. So once you do that, you can then you can know the center is somewhere around here. That's minus 4, comma minus 3, right? The center is x squared plus y squared minus 6x plus 8y plus 9 equals 0. So we know the center is 3. So this 3 now, yeah, comma minus 4, like this. So that's 3, comma minus 4, like that. And of course, the radius, then we can then measure from here to here, for instance. So since you know this point, you also know this point, which is passes through, so you can calculate the radius based off of that. Okay, so that's so interesting. So in summary, you can see that uh when you have the center of a circle at the origin, the equation is given as x squared plus y squared equals r squared. If you have the center at h comma minus k, so you have h minus x minus h squared plus y minus k squared equals r squared. And then you can, expanded equations can be rewritten into standard form using completing the square method. Okay, after that, you have some practice questions to try your hands on, right? So the first one says, write the equation of a circle with center at the origin and radius 7. That's easy. X squared plus y squared equals 49. That's all. That's x squared plus y squared equals 7 squared. Then the next one says, find the equation of a circle with center 3, comma minus 4 and radius 5. Easy. That's x minus 3 squared plus y plus 4 squared because of that minus. So that's y minus minus 4. That's y plus 4 squared equals 5 squared. That's 25. That's x minus 3 all squared plus y plus 4 all squared equals 25. So you can try your hands on the rest like that. With this, I come to the end of this interesting video about the standard equation. When you talk about standard equations of a circle, let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I say thank you very much. If you haven't subscribed, of course, you want to do that right away so that you can always get, and of course, you want to hit the notification bell too. So you can always get alerted each time a new video is released. Having done that, you want to take it a step further by, by clicking on join to become a member of this channel so that you can get some special privileges. All right. Ultimately, don't forget to comment, like, and share. Comment, like, and share so that you can actually get some, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.